Hey guys, I'm going to do today's video a little differently. We usually do movement how-tos, but Jason's field of study is actually not just physics, but astrophysics. And I know all of exercise is physics, but I wanted to, out of my own curiosity, I just have this default curiosity for a lot of things. So I asked Jason if he would do us a favor and go into like, what would a beginner, how do you even open up that field? Like this is the extent of my knowledge of physics. We've got classical Newtonian mechanics here, the relativity equation. I don't even know what that means. I just know that that's the thing.
Looks good though.
Well, thanks. And then I know that before people used to think that the Earth was the center and then the sun was the center, and then they revolved around each other, and then now everything's curved or relative. So Jason, how would you introduce the field of astrophysics to a regular person?
Yeah. So a lot of people don't know what astrophysics is, but it's,
Right.
In a nutshell, the study of physics, but out in space, out in the universe.
Okay.
So it encompasses everything from the creation of the universe to what's going on, how stars are formed, how planets rotate, that kind of stuff.
Yes.
And eventually to what's going to happen at the end of the universe.
Oh, okay.
So it's really cool.
So given that we, like our tools, we're going well over a minute now. I'll post the rest on YouTube. But given that our tools of observation and measurement are, I'm not going to say limited, but they're always evolving, right?
Yes.
And to outside of satellites and just things we've launched into space, our tools to actually measure outer space are limited.
Yes.
And so too is our ability to cover the kind of distances that we've observed, and therefore our ability to weigh, measure.
Yes.
You know what I mean? And so, how do we reconcile the tools that we have now versus what's actually observable and measurable? Is that also within the field of astrophysics?
Yeah. So
okay.
It's very much an observational science.
Yeah.
Because you're not just going to go to some other planet or
Sure.
go to some other galaxy and gather measurements.
Yes.
So as technology gets better and better, we're able to measure those things much more finely.
Oh.
And that's like measuring how much light is emitted from stars. So you can measure what their energy level is and what their distance is. Stuff like that. So yeah, as technology gets better and better, those measurements can get finer and finer.
Okay, yeah, because I mean, we were talking earlier. This is what we talk about during our sessions. We were talking earlier about how I know that when Einstein came out with his relativity stuff, it didn't destroy Isaac Newton's observations. It just had to, the domain had to be tightened a little bit.
Yes.
And so, is it reasonable to observe? I think who was the Earth-centric guy? Copernicus.
Copernicus was the first one to suggest that everything rotated around the sun. The sun,
okay. So solar. So Copernicus is solar-centric.
Everything before that was people just assumed that we're important. Everything revolves around the Earth.
Okay, so
and it took hundreds of years after that for everyone to finally accept it.
What was Galileo's contribution? Was he?
Galileo was the first person to use a telescope.
Okay.
So he was the first person to see, I don't know exactly what, but planets further out. Like we knew about the close planets, Mars, Venus. Yep. But he discovered some of the ones that were further out that you can't see with the naked eye.
Okay. So given what we have right now, 2018, what do you see as the next? I don't know to what extent scientists try to predict the next big thing, but what do you see as the next big scientific discovery or technological advance?
So with Elon Musk,
I was actually going to bring him up.
Making space travel much more affordable.
Yeah.
It's looking, and he has this whole plan for Mars travel. It's looking more and more reasonable that we come up with a plan to get humans on Mars. In the next 10, 15 years.
Awesome.
So that's coming up. In the last year.
So actually, colonization would be the next step.
Yeah, maybe not colonization, but just studying. Could we terraform it, or looking for life on Mars?
Okay.
If we found evidence, because there was water and ice on Mars.
I did not know that.
But long since dried up.
Sure.
But if we could find evidence of life on Mars, that would be huge for just science in general.
Okay.
So I think that's pretty realistic.
Because where I was gonna go was actually this could totally be my sci-fi mind coming out, but I was gonna ask how far we are from something like, for lack of a better term, warp speed or light speed, or even the folding of space and time. You know what I mean? I know that's kind of a far off concept now, but so too was the light bulb at one point, right? So,
yes. So we're not anywhere near.
We're not anywhere near that. Yeah.
For people-sized objects.
Yes.
But very, very small light objects.
Really.
Can get closer and closer to the speed of light.
Oh.
The less mass an object is, the easier for it to go faster and faster.
So would this be because I know a while ago there was I forgot what it's called, the Hadron Collider or something like that.
Still
okay.
On.
Okay, so is that
that's a big particle collider where they shoot particles in a massive circle.
Yes.
And since they're so small, you can get speeds up to the maximum speed limit of the universe is the speed of light.
Sure.
In your equation right here, C.
Okay. Can you all right, how about this? Can you explain that? Like what does
this one?
Yeah, what does E and what does E
E is energy.
Yeah.
M's mass.
Okay.
C is the speed of light.
Uh-huh.
So this equation is from Einstein's theory of relativity.
Yep.
And it's showing the conversion between energy and mass.
Okay.
So if something has a mass associated with it, it has like a natural energy.
So is this equation how people are able to create energy from something like waterfalls? Or is that too?
So waterfalls, that's just kinetic energy. That's just from motion, moving from or potential, moving from up here, where it falls this much, and due to gravity, it gains this much speed and energy.
Gotcha.
This is for small particles.
I see.
Moving close to the speeds of light with very little mass.
Got it. Awesome, dude. I love talks like this. I think they're very stimulating and important. Would you be open to being a guest on my podcast at one point?
Oh yeah, let's talk about it.
All right, awesome, dude.
That'd be great.
Dude, thanks a lot. This is now 6.5 minutes, which was well over the 1 minute that it was supposed to be. But dude, thanks a lot, man. I appreciate it.
No problem.
Okay.
Bye, guys.
Oh, wait a minute. If people watching want to contact you, what's the best way to contact you?
Contact me?
Yeah, like if they have questions.
You can get my number from Zeb.
Okay, yes, there's that.
You can email me at Jason A. Rothenberg.
Okay.
ROTHENBERG.
Yep.
At Gmail.
Are you on the social medias at all, or is that something?
Not really.
Okay.
I'm on Instagram.
Okay.
At JRothenbro.
JRothenbro.
Yeah.
Awesome.
But that's about it.
Okay, cool. Thanks, Jason. Bye.